This is Mr. Beck Does Your Homework. This is AP Physics, Homework 12.2, questions 10 and 11. Question 10 reads, a thin film of cryolite, index of refraction 1.28, is applied to a camera lens, index of refraction 1.54. The coating is designed to reflect wavelengths at the blue and transmit wavelengths in the near infrared. What minimum thickness gives high reflectivity at 512 nanometers? So I want a lot of reflection at 512. So what I have is light coming from the air, hitting the cryolite, and then hitting the glass. So it's going to reflect off of the air, it's going to reflect off the cryolite. And so this is where I need some knowledge of what's going on with the reflection. If I look at the indices of refraction, I see that it starts in air with an index of refraction of 1, the cryolite has an index of refraction of 1.28, and the camera lens has an index of refraction of 1.54. I can see these are in order. Now, if you remember, our phrase is in order, no quarter. So if they are in order, which I just determined, this is where we are. Yes, it's in order. So a half will reflect and a quarter wavelength will not reflect. What I'm looking for is I want it to reflect wavelengths, high reflectivity at 512 nanometers. So I'm looking for yes reflect. That means I want a half wavelength. I want this thickness of the coating to be 1/2 wavelength. So I need to know the wavelength of the light here in the coating. Now I know that N1 lambda 1 equals N2 lambda 2. Lambda 2 is in here, and I need a half of that wavelength to be the thickness of this coating, so I've got to figure out what lambda 2 is. I know N2 is 1.28, I know that N1 is 1, and lambda 1 is 512 nanometers. So 1 times 512 nanometers equals 1.28 times lambda 2 in nanometers. Well, that's kind of convenient. If I even leave out the times 10 to the minus 9th, I'll get lambda 2 in nanometers. As long as I've got nanometers in, I'll get nanometers out. So once I've got 512 nanometers there, and I solve for this, I'm going to get lambda 2, and then I want a half of that. So take lambda 2, divide it by 2, and that should be the thickness of that film. Now in the same way, I have to figure out the minimum thickness that gives high transmission at 1024. High transmission means no reflection. So I've got in order, no quarter, so I want no reflection, so here I am at a quarter wavelength. But now, instead of the 512 nanometer that I had before, I'm going to deal with 1024 nanometers in part 11. So I have to recalculate, but this time I'm going to find 1024 as my lambda 1 because that's the light that's coming in, 1024 nanometers. I still have 1.28 and I still have 1, so now I can find lambda 2 here, and I'm going to want a quarter of that wavelength. So a quarter of that wavelength. Now you might notice something about these numbers, but still, solve for lambda 2, your new lambda 2, and take a quarter of that, because I want no reflection of that, and that should be your answer.